240-volt appliance will not operate correctly or safely without a neutral wire connection. The neutral wire's function is to provide a return path for the electrical current back to the power source, effectively closing or completing the electrical circuit. In the absence of a neutral wire, the electrical current cannot flow correctly through the appliance's internal components, leading to a number of potential problems. Firstly, the appliance is likely to overheat. Electrical appliances are designed to operate within specific current ranges. Without a proper return path, the current flow becomes erratic and can exceed the design limits of the appliance's components. This excessive current generates heat which, if left unchecked, can damage the appliance and create a fire hazard. Secondly, the appliance will malfunction. Many 240-volt appliances, such as clothes dryers and stoves, incorporate 120-volt components for functions like timers, lights, and electronic controls. These 120-volt components rely on the neutral wire to provide the voltage difference between one of the hot wires and neutral. Without the neutral, these components will not receive the necessary voltage and will fail to operate. The ground wire serves a separate but equally important function. It provides a safety path for excess current to flow in the event of an electrical fault. This is different from the neutral wire, which serves to return the normal circuit current. An electrical fault can occur due to damaged insulation, loose wiring, or other internal problems within the appliance. If a fault occurs and the appliance is not properly grounded, the excess current will seek the path of least resistance, which could be through a person touching the appliance. This can result in a severe or even fatal electric shock. With a properly connected ground wire, the excess current will flow through the ground wire back to the electrical panel, tripping the circuit breaker or blowing a fuse and cutting off the power to the appliance. This protects the user from electrical shock and prevents further damage to the appliance. There are specific codes that address the necessity of ground wires. According to the National Electrical Code, also known as NEC, all appliances must be grounded to ensure electrical safety. The NEC provides detailed requirements for grounding electrical systems and equipment, including appliances. Section 250 of the NEC covers grounding and bonding requirements. It specifies how to properly ground appliances to minimize the risk of electrical shock. The absence of a ground wire can lead to several hazards. Firstly, there is an increased risk of electrical shock. Without a ground wire, a fault in the appliance can cause the metal chassis or enclosure to become energized. If a person touches the energized appliance, they can receive a severe electric shock. Secondly, there is an increased risk of fire. A ground fault can cause arcing and sparking, which can ignite flammable materials nearby. The ground wire provides a low impedance path for fault current, allowing the circuit breaker to trip quickly and energize the circuit, preventing a fire. Thirdly, there is potential damage to the appliance. Without a ground wire, a fault can cause voltage surges and spikes that can damage the appliance's electronic component. The ground wire helps to stabilize the voltage and protect the appliance from damage. Certain types of appliances are more susceptible to problems without a neutral or ground wire. Electric ranges often have 120-volt components for the oven light, timer, and electronic controls. These components require a neutral wire to operate. Without a neutral wire, these components will not function. Electric clothes dryers typically have a 240-volt heating element and a 120-volt motor for the drum. The 120-volt motor requires a neutral wire to operate. Without a neutral wire, the dryer will not tumble. Electric water heaters are typically 240 volts and do not have any 120-volt components. However, they still require a ground wire for safety. Without a ground wire, a fault in the heating element can cause the water heater tank to become energized, posing a shock hazard. If an appliance is not working properly due to a missing neutral or ground wire, it is important to take the following steps. Firstly, disconnect the appliance from the power source. Turn off the circuit breaker that supplies power to the appliance to prevent electrical shock. Secondly, contact a qualified electrician. An electrician can inspect the wiring and determine the cause of the problem. They can also install a new neutral or ground wire if necessary. Thirdly, Do not attempt to repair the appliance yourself unless you are a qualified electrician. Electrical work can be dangerous and should only be performed by someone who is trained and experienced. To summarize, a 240-volt appliance will not work properly or safely without a neutral wire. The neutral wire provides a return path for the current, and the ground wire provides a safety path for excess current. Without these wires, the appliance is more likely to overheat, malfunction, cause an electrical shock, or start a fire. Always ensure that appliances are properly wired and grounded to prevent electrical hazards. The NEC specifies minimum wire gauge requirements for different amperage ratings. For example, for a 20 amp circuit, a minimum of 12 American wire gauge, also known as AWG, copper wire is required. For a 30 amp circuit, a minimum of 10 AWG copper wire is required. For a 40 amp circuit, a minimum of 8 AWG copper wire is required. For a 50 amp circuit, a minimum of 6 AWG copper wire is required. These wire gauge requirements are based on the ampacity of the wire, which is the maximum amount of current that the wire can safely carry without overheating. It is important to use the correct wire gauge for the circuit to prevent overheating and fire hazards. When installing a new circuit for a 240-volt appliance, it is important to follow these steps. Firstly, determine the amperage rating of the appliance. This information can be found on the appliance's nameplate. Secondly, select the correct wire gauge for the circuit. Use the NEC wire gauge requirements to determine the minimum wire gauge required for the amperage rating of the appliance. Thirdly, install a properly sized circuit breaker. The circuit breaker should be sized to protect the wiring from overcurrent. Fourthly, install a grounding electrode system. The grounding electrode system provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. The grounding electrode system should consist of a ground rod, ground plate, or other approved grounding electrode. Fifthly, connect the appliance to the circuit. Use the correct wiring connections to connect the appliance to the circuit. Ensure that the neutral wire and ground wire are properly connected. It is important to note that electrical codes and regulations vary depending on the location. Always consult with a qualified electrician to ensure that electrical work is performed in accordance with local codes. Ignoring the neutral wire can create what is commonly called an open neutral situation. This condition can be dangerous because it can cause voltage imbalances in the electrical system. In a properly functioning electrical system, the neutral wire carries very little current. However, in an open neutral situation, the neutral wire becomes disconnected, causing current to flow through other paths such as the ground wire or other appliances. This can cause voltage to rise on some circuits and drop on others, potentially damaging electronic equipment. In addition to electrical shock and fire hazards, a missing neutral or ground wire can also cause electromagnetic interference, also known as EMI. EMI is a disturbance caused by electrical or electromagnetic radiation that can affect the performance of electronic equipment. A missing neutral or ground wire can create a path for EMI to radiate from the appliance, interfering with the operation of other electronic devices nearby. This can cause problems such as static on radios, interference with television signals, and data errors on computers. To prevent EMI, it is important to ensure that all appliances are properly grounded and that the neutral wire is properly connected. The grounding system should be designed to minimize EMI and provide a low impedance path for fault current. Additional measures can be taken to reduce EMI, such as using shielded cables, installing filters, and locating sensitive equipment away from sources of EMI. The NEC provides specific requirements for minimizing EMI in electrical systems. Section 250. 146 of the NEC covers bonding requirements for reducing EMI. It specifies how to properly bond metal parts of the electrical system to minimize EMI. The NEC also provides requirements for installing surge protective devices, also known as SPD, to protect electronic equipment from voltage surges and spikes. SPD can help to reduce EMI by suppressing voltage transients that can cause interference. Therefore, proper neutral and grounding connections are crucial not only for safety, but also for ensuring the proper functioning of electrical appliances and minimizing potential interference with other electronic devices.